Hello all, today we are solving LeetCode problem number 3314, construct the minimum bitwise array 1. So we are given an array nums which contains prime integers only and of size n, and you should construct an array called ans and which is of length n as well, and each index in the ans should satisfy this condition. So which is ans of I with bitwise or with ans of I plus 1 should be equal to nums of I. So, and we have to construct this and return the complete array. So that is all about the problem. So let us understand with the first example. So we are having this particular input array, and which is 2 3 5 7, and here in the explanation they are given that the output is -1 1 4 and 3. And one thing to note is if you cannot find a condition, if there is no number satisfying the condition, you have to return -1 as the player and in the place of the in that particular index, right? And the value must be minimized. It should be the minimized value basically. So here they have given the explanation for the one, the first example 1, and for I is equal to in 0, there is no value and 0 that which satisfy the condition. So which is ans of 0 or ans of 0 plus 1 is equal to 2. So that because of that reason they have returned 1, and here I is equal to 2. In that case ans of 1 is the answer, because ans of 1 which is 0 1, or with ans of 1 plus 1 which is 2, which is 1 0, right? So the or of this result in 3. Yeah, 1 plus 1, this will result in 3 1 1, right? In bitwise this is represented as 3. So this satisfies the condition, and because of that we are getting the nums of I. So because of that we are getting 3, right? So similarly repeating all these, we are getting this as the answer. So for better understanding, let me draw the binary representation of a numbers, and we can check. So there is one example, we have 11 and 13, and this will return the array as 9 and 12. The constructed ans will be 9 and 12. Because 11's binary representation is 1011 and 13th is 1101, right? So here if we have 9, the 9 binary representation is 10. This is 9th binary representation at the number 9, and the binary representation of number 9 is this, and plus 1 is 10. So because of that this is 10, and the XOR operation of these binary bitwise OR operation, this result in 11, right? So which is 1011, right? So let me show that 1001 1010 bitwise R is 1 and 101, which is nothing but 11. So similarly here this will be 12 and 1, right? So because of that this will be 13 1 101, and oops, this is not this 0001 and 1100. This is 11101, which is nothing but 13, right? So because of that this is 12. So this is how we solve this problem, and how to write this algorithmically. Let me write that down. How are we solving this? How are we coding this basically? So you iterate through nums, right? And you take num n as the value, right? And now we will be checking the binary value from 1 to n, which will take some the time. consume so much time. So instead of that, we can check for binary value starting from 1 and doing left shift. So we have 2 power 0 as 1 and 2 power 1 as 1 0 and 2 power 2 as 1 0 0. So in this way we do left shift and we check the condition basically. So when nums of I and the digit, which is this is the digit equals to 0, then in that case nums of I minus previous digit gives the answer of I. That will be the minimum also. So in this way you append complete append ans of I and return. Right, so now this will be a bit of confusion here. So let me run through the next example, the first example. So we are given basically the array is 2 3 5 7, 2 3 5 7, right? So now consider 2 binary representation is 1 0. So we will have 0 1 as this is the binary representation of 1, the digit as 1 equal to 1. So there is no previous digit existing. So because of that you cannot subtract the nums of I minus previous. So this will not give any result. So because of that we have -1 here. So and the first value will be -1, and for 3 we have 1 1. We try for 0 1. So this will not give 0 0. The AND operation, basically the AND operation will not give 0 0. And we try the next one which is 1 0. Even this will not give any 0 value, because of that this is 1, this is 2, and then we try for 1 0 0, which is 4, right? So here this gives 0. So because of that this is the previous value. So nums of I minus previous implies 3 minus 2, which is 1. So we go here and append here, right? So now we are having 5. So 5 can be represented as 1 0 1, right? So clearly we know that this can be solved by 1 0 0, which is 2. So the previous one is 1, right? So because of that this is 0 and the previous one is 1, and the nums of I is 5. So 5 minus 1 implies 4. So we append 4 here. Then the last value is 7, right? 7, and 7 can be represented as 1 1 1. And now to get 0 value here, this should be 8. So 1 0 0 0. This is sorry, this is 4. No, 100 is 4. So this is 8. So the previous value will be 4, right? 1 0 0. The bitwise left. So this will be previous value will be 4, and because of that 7 minus 4 is equal to 3. So we go here and append 3. So now that is we have done processing this, and this is the answer we return. Okay, let us check this with the given answer, which is -1,143, which is the same answer here. So with all this observation, let us go ahead and code this up. So the time complexity will be big O of n, since we are processing for a linear loop for iterating through nums, and log m, because the m is the largest number which we will be iterating through to form the left shift operation. So because of that, this will be big O of n cross log m times. So we have to return the answer, right? So that should be ans, and now we start iterating. So for I in range len of nums, and we start the num value be -1, right, and digit equal to 1, because we start from that. And now we have to iterate by doing the left shift operation and checking the and condition, which we mentioned, which I showed in the video. So while nums of I and digit not equal to 0, we iterate this loops that time, and we in each iteration we do left shift operation, and we just track down the previous value there. So here we update the num, so for us the previous value, so this will be the previous value is equal to nums of I minus digit, right, and digit oops I digit left shift equal to 1, left shift by 1. And now end of iteration, you append the result, because you got the result and you break out of the loop, which means you got the ans value. So ans dot append the value num, right, and you repeat this, and you in the end you return. And this is a pretty efficient solution. Thank you.